Chapter 7 Couplers 7-1 TM55-203 Maintenance of a Railway Car. Chapter 7 Couplers 7-1 Automatic couplers such as T or some Type E in general use in North America are completely automatic except for aligning with the knuckle to receive the mating of the knuckle of the car to be pulled and safely operated from alongside with the car, raising the upper uncoupling lever. Type D and Type E couplers can be rigged to either bottom or top operation according to the location of the locating or lock lifting device on the car. Type D couplers were may be found pre-1933 cars on Canos, although they are no longer acceptable in interchange. They can be used in installation cars in Canos, the U.S. built equipment on other countries. Type H swivel shank and tight lock couplers are generally used only passenger equipment. All automatic couplers are similar in components and method of operation. The working parts of D and E couplers are interchangeable, however, exceptions for the knuckle pin. No parts of the Type H couplers are interchangeable with any other type, although the parts are the same in names as it is in the most common Canos. Only the Type E is discussed in detail. With the Wilson coupler used in extensive foreign areas, it is also discussed. 7-2 D couplers. The basic components consist of the body of the knuckle lock, the knuckle throw, and the knuckle pin in Figure 7-1. This part remains same whether the coupler is top operated or bottom operated. Equipment in type operation is the lifter is used in additional to these use. The coupler is rigged for the bottom operation. A lock lift toggle is used in pivot and lugs provided by the bearing for a lifter. Because of the similarity of these parts with like parts of the Type E, only the later type will be discussed herein. 7-3 Type E coupler. In general, the Type E coupler is in the Type D within many improvements and the refinements is so designed that only the actuating parts need to be changed in order to fit the coupler in either bottom of the rotary operation. Uncoupling lever is simplified and can be located in the position that is convenient to the trainman of the easy operation. A typical E coupler is depicted in Figure 7-2. Component parts. The Type E coupler consists of the following parts. The function is indicated. 1. The body. The main section of the coupler consists of the coupler head, the horn, the guard arm, and the shank and the butt. And the coupler head at the head house is the operating components. 2. The knuckle. The rotating hook is hinged on the knuckle pin into the head, held to connection with the rotating knuckle. The knuckle lock. 3. The lock. The key-shaped block of the drop is placed in with the knuckle is closed and prevents an uncoupling. Knuckle throw. The device which throws the knuckle upon the uncoupling lever is raised. 5. The knuckle pin. This action is a pivot of the knuckle holds the knuckle pin into the jaws of the coupler. 6. The lift of the mechanical is moved on the uncoupling lever of the knuckle lock and open the knuckle. 7. The toggle. This works with the lever pivot of the lugs to provide means of lifting a knuckle lock on. See operation. To throw the knuckle, i.e. uncoupled, the lock is lifted above the lock set of position until the fulcrum is forward slide contact shoulders with the coupler head. The contact stops and the vertical movement of the lock forces it to rotate its fulcrum. Give the lock key and positive movement into its rear. It rotates the knuckle throw. It's about as true end of the lip of the thrower contacts of the shoulder underside of the knuckle, throwing the knuckle open, unlock it into it, and if uncoupled coupled to another. 7-4 tight lock couplers. Type H tight lock couplers entirely new design and incorporates a new number of distinct features in outward appearances. It's similar discussed in the consistency essential for the same named parts. Paragraph 7-2 certain surfaces of coupler head knuckles and locks and knuckle pin holes in both head and knuckle are of the machine finished to meet the fitting tolerance required. In addition, with aligning the wings, extending to both sides of the increased in coupling efficiency, the type of coupler is normally operated on the left side of the car. Single type of lock assembly, if it can be adapted to a double type lock lift assembly for operation from either side. The principal advantages of the coupler design: the reduction of the counter slack, elimination of the noise caused by coupler slack, reduction of fatigues and the coupler faces knock wall, and elimination bolt fitting stress, and single slack is reduced and resulting in a buffeting and joining is reduced. The surface lift of the coupler is needed 7.5. The maintenance Conos type of coupler is a general design specification requirements regulations will dictate and when and what coupler maintenance actions are accomplished. The Conos type of coupler previously discussed in two or more frequent requirements for the maintenance are cited below. For familiarity with the AAR rules and Army regulations are similar as reported by the operation of functions is essential. The good maintenance frequency inspection detect defective couplers types D and E. Will distance between the point of knuckle and guard arm extent of 5 and 5/16 of an inch is measured by the gauge of figure 7.3 must have and defective parts and parts renewed by bringing coupler within the received gauge of 5 and 1/8 of an inch is measured by the gauge of figure 7.4. If the coupler is out of gauge, the body must not be renewed unless the application of the second-hand recondition of the knuckle lock and pin or any or all not bringing in the record a gauge of 5/8 of an inch. B. The coupler height. The coupler height must be maintained within proper limits. The height of the coupler is measured at the top of the rail center of out of face coupler knuckle of empty freight cars within the coupler heights measuring 32 and 1.5 inch or 32 and a half inch and less be adjusted by 34 and a half inch. Loaded in freight cars with adjusted must be not extended to 33 and a half inches. When adjusting coupler heights, the coupler should be first placed in per alignment with drafting gear shims 1/4 of an inch thickness and measure as required may be applied to the carrier iron to adjust the coupler height. If the shims less than a 1/4 inch thickness is required, realignment is unnecessary after the coupler has been placed in proper alignment by shimming care of the height is not less than a half inch excessive of the minimum dimensions specified in further adjustments and is made to the truck spring and center plates and journal boxes. Here you see figure 7.3 using the contour gauge of 5 and 5/16 of an inch. This is a steel plate hardened essential dimension and this is your worn distortion contour and your 5.5 inches original and contour. It's basically another flange cord. Use a worn limit. See the knuckles. Excessive knuckle play within often results of exceptional shock and jar. The switching may be cause the guard arm to coupler and to be bent out of the contours. This causes the opening of the knuckle to become out of gauge and allow knuckles of the coupler of an adjoining car to slip out. The distance between the guard and the arm knuckle meet the gauge's requirements to exceed 5/8 of an inch as shown in figure 7.4. And knuckle opening it must be essentially large. This conditional may be recorded holding up a welding or knuckle where it makes a contact with the block the fulcrum. However, the new coupler may be installed unless there is knuckle in under these circumstances. If the excessive opening is due to the worn knuckle and the knuckle pinhole replacement, knuckle pinhole replacement of the knuckle may be required. A knuckle worn from the face of the back bearings will be condemned by the gauging. Such knuckles may be replaced. Knuckles are sometimes cracked down to the fat. Such cracks are dangerous and the knuckle should be removed and replaced. Knuckle pins. The knuckle pins are frequently found defective. When placed in pins, the proper size and must be used. And larger pins cracked and pinhole casting. Smaller, undersized pins will be loose and will be creating slack, permitting pass and locking on adjoining cards between knuckle and guard arm. Cotter keys should not be exceeded. Not use knuckle pins except for fixed and gondola hopper cars. Slack. If any slack exists between the coupler and the Fowler plate and draft gear body, the cause should be determined and remedial actions should style. Slack usually used in worn coupler butt and may be due to the defective draft gear. Chapter 6. Worn coupler butts may be built into the electric welding and shim plates inserted to eliminate slack. 5 general pairs of rivet shank couplers commonly used in Army rolling stock are attached to the draft gear yoke and the draft keys inserted laterally through the holes of the yoke key. Coupler shank and bolt is supported underneath the coupler carrier. The iron secured to the put on the underframe shim wear plate and between the carrier, the shank and the coupler. To remove the coupler, the following procedures is assembly to reverse order in the reverse order. 1. Disconnecting the uncoupling lever from the coupler lock lifter. 2. Knuckle pin from the knuckle. 3. Remove the lock and lock lifter knuckle thrower. 4. The cotter keys and the bolt from the draft key. 5. Drift out the draft key from the tapper. And 6. Slide a coupler backward until the third two-thirds of out. 7. Place a bar immediately a long bar and pipe immediately behind the coupler head under the thickness portion of the shank and between the two men holding the bar and the pipe on one hand each side, using the other balance in the coupler and lift and lower to the ground. Remove yoke and draft gear, etc. as required. Paragraph 6.4. 7.6. Couplers of overseas railway equipment, within exceptions of Hook and Link and Wilson couplers set to 41 inches. Couplers height in predominantly overseas areas. Exceptional are these areas are such as Korea, Japan, and China, where AAR type of automatic couplers are used. The state previously neither Hook nor Link Wilson couplers transmit but directly center still through the draft gear, but loads are taken up two sides of the buffer coupler and height at the top of the rail. Each buffer approximately 35 inches longitude center of the car. Design loads are both buffers and hicks and links of the coupler. The design of the fixing train tonnage is usual life of the coupler is directly related to the amount of misuse brought about by the overloading. The outstanding characteristics of Hook and Link coupler is designed to provide no built-in slack between the cars, and links are turned to the tight of the turnbuckles loosen at the slack. The two couples divided and illustrated in figure 7.5, 7.6, and figure 7.6 shows the slide buffer arrangement. 7.7. A. General. The standard European coupler consists of three main parts. At each end of these parts are a screw coupling and a draw hook and a two buffer assembly illustrated in figure 7 dash. The draw hooks form 7.6. The draw hook forms part of the underframe of the screw. The coupling mounted on the base of the hook. The two buffer assemblies are located on each side of the hook. A screw coupling and toward the side of the car is shown, and the screw coupling consists of the clevis screw lever and the shackle, and each of the buffer assembly consists of the housing attached to the framework of the craft, which has had a spring-loaded section extending to the housing. B. The operation when the cars are hooked. The shackle of the screw coupling on one car is hooked over the draw hook over the hook of the car. Tightening of the lever turns the screw jaws and the screw coupling. The coupling is tightened until all slack is removed. The face of each buffer should be in contact with the corresponding buffer of the other car when the train is started and running, and screw coupling carries the pulling load. If rolling stops in starting, and buffet protects the car and landing. Obstruction of all jots and shocks. Prevention of the cars of running together. The function of the draft gear, the UST type equipment on curves of the buffer and sides of the cars inside the car curve are based on farther than housing. The buffer is outside of the car, extends the house of housing because of the pressure extending the springs. The steady of the car during the runs. Uncouple the screw coupling. The levers must be loosened, and loosening the screws in sufficient slack of the shackle off the draw hook. 7.8. Wilson's automatic couplers. A. General. Wilson coupler is usually some overseas areas. The automatic coupler works on some named general principles of the AAR coupler used in the United States. One's made a mark in each of the capable coupling of the continental Europe. The standard Hook and Link coupling means of this transition device, the standard clevis and a screw discussed in paragraph 7.7. The principal components shown in figure 7.7 include the following: friction buffer 1, the friction buffer 1, the Wilson coupler 2, the buffer space 3, the coupler support 4, the drafter gear and yoke 5, and transition device 6. The operation of these two types of Wilson couplers is illustrated in 7.8 and 7.9. The maintenance of the operating parts illustrated in 7.8 and 7.9 are removable, accessible, maintainable for maintenance, and the follow steps is taken an inspection of the type of the coupler. 1. Visual inspects of the operation parts of the coupler to see that they are not cracked or broken. Test the occupying device for proper operation. Check all the visible and draft gears, cracks, and damages. 4th, coupler. The hard and center line of the coupler should be 41 inches at the top of the rail. Buff the center line must be 42 inches from the top of the rail. 5. Inspect the friction buffers and transit screws device of loose, missing, and cracked parts. C. The removal and disassembly. The Wilson type of coupler is removed from a car in the following manner: 1. Uncoupling rigging, and 2. Support coupler weight and remove coupler coupler support of the coupler from removing the 4 holding nuts at the bolts. 3. Remove the coupler pivot and retaining key through the cutout hole provided by the side of the coupler and drop out of the pin. Disconnect the coupler of the drafting gear and yoke and pull out the remove the thrower arm bolt on nut. Remove the thrower lock and filler block. 7. Clean and inspect all parts serviceability. D. Responsible 1. Replace all damage of the worn parts. 2. Assemble and install parts of the reverse order of the removal. 3. Gauge the coupler when installation car has been completed. Adjust and as required. This is 7-7, a typical Wilson arrangement. If 1, you see the friction buffer. 2, you see the Wilson coupler. 3, the buffer space. 4, the coupler support. 5, the draft gear and yoke. 6, your transition device. Here is operation parts on Type E and Wilson couplers. 1 is the coupler. 2 is the thrower and bolt and nut. 3 is your lock. 4 it goes to your support hook. 6, 5 your thrower. 6 your filler block. This is an 7-9 operation of an L. Wilson caliper. You got your body, your lock coupler, your throw coupler, your lever thrower coupler, your lock set coupler, your lock retainer coupler, and your bolt and your lever and coupler. Chapter 8. Car brake equipment.